Hello my friends and welcome back to the Today Machine channel. In the first stage of the production tires, rubber is mixed with fillers like clay and carbon black in a rubber mill. At the final stage of mixing, sulfur and curing agents are added. The mixed compounds are used for various parts of the tire, such as the air-holding inner liner or the wear-resistant tread. After testing, the rubber is formed into sheets, cooled, and weighed for further processing. Different components of the tire are produced separately. These include bead wires, reinforce the tire and help it stay on the rim. Rubber-coated cord, provides strength and flexibility. Extrusion and calendaring. The rubber compound is heated and extruded into tread and sidewall shapes. The inner liner is calendared, while the tread and sidewalls are cut to precise lengths. All components are assembled on a tire building drum. The process starts with placing the inner liner, sidewalls, and bead core. Multiple plies of fabric and belts are applied, followed by the tread rubber. Once all layers are assembled, the result is a green tire, which resembles the final product. The green tire undergoes vulcanization, where it is placed in a curing mold, heated, and reshaped. During this process, sulfur links the rubber polymers, transforming the tire's structure into a durable, elastic product. The curing process for passenger tires takes a few minutes, while agricultural tires may take up to 2 hours. After curing, the tire is trimmed and inspected for defects. Tests are performed to measure its uniformity and compliance with specifications. Tire retreading, a process that involves replacing the worn-out tread of a used tire with a new one, has been a popular practice in various industries for decades. It offers significant economic and environmental benefits, particularly for commercial vehicles, including trucks, buses, and aircraft. However, while tire retreading has many advantages, there are also disadvantages that users should consider. We will explore the key benefits and drawbacks of tire retreading. One of the most significant advantages of tire retreading is the cost savings. Retreading a tire can save between 30% to 50% of the cost of a new tire. For example, a new commercial truck tire may cost between $300 and $500, while a retreaded tire costs between $90 and $140. For companies with large fleets, such as transportation or logistics firms, these savings can add up to thousands of dollars annually. The reduced cost of retreaded tires also makes them more accessible for smaller businesses or individuals who are looking for a cost-effective option without sacrificing performance. In addition, since many tires can be retreaded 2 or 3 times, the overall savings over the tire's lifetime are substantial. Tire retreading is an environmentally friendly alternative to buying new tires. The process conserves natural resources and reduces waste. A significant portion of a tire's raw materials, particularly oil, is used in the production of the casing. By reusing the casing, retreading saves approximately 15 gallons of oil per commercial truck tire and 7 gallons per passenger tire. This reduction in raw material consumption directly contributes to lowering the environmental footprint of tire manufacturing. Additionally, retreading helps reduce the number of tires that end up in landfills. In the United States alone, approximately 300 million tires are discarded every year. Retreading can reduce this number by up to 80%, decreasing tire waste and the associated pollution. Overall, the process aligns with sustainability efforts by promoting recycling and reducing the demand for new tires. Retreading is also a highly resource-efficient process. Since up to 75% of a used tire's casing is retained, the need for new materials is significantly reduced. This conservation of resources is particularly important for industries with high tire usage, such as trucking and aviation. Furthermore, retreading uses less energy than manufacturing a new tire. It is estimated that the energy required to produce a retreaded tire is only 30% to 50% of that needed to produce a new one. This energy efficiency makes retreading a more sustainable option in terms of both resource use and production emissions. In turn, companies can lower their overall carbon footprint by choosing retreaded tires. Contrary to common misconceptions, retreaded tires can perform on par with new tires when properly retreaded. Modern retreading technologies, along with stringent quality control processes, ensure that retreaded tires are safe, durable, and capable of withstanding heavy use. For example, many commercial truck retreaded tires have a mileage similar to new tires, often ranging between 100,000 and 150,000 miles, depending on road conditions and maintenance. Furthermore, retreaded tires are used in industries with high safety standards, such as aviation and public transportation, proving that they can meet demanding performance requirements. With proper maintenance, retreaded tires can serve as reliable alternatives to new tires. One of the key disadvantages of tire retreading is the potential for variability in quality. While modern retreading techniques have improved considerably, the quality of the final product largely depends on the condition of the original tire casing and the retreading facility's processes. Not all casings are suitable for retreading, and if a damaged or weak casing is used, the tire's lifespan and safety can be compromised. Additionally, some retreading shops may not follow strict quality control measures, leading to inconsistencies in the performance of retreaded tires. For this reason, it is crucial to choose reputable retreading companies that adhere to industry standards to ensure safety and performance. Although tire retreading is commonly used for commercial vehicles, such as trucks and buses, it is less common for passenger cars. One reason is that the cost-effectiveness of retreading depends on the tire's size and usage. Passenger car tires, which are generally smaller and experience less wear than commercial tires, may not benefit as much from retreading. Additionally, some passenger vehicles, especially those designed for high-speed performance, may not be suitable for retreaded tires due to safety concerns. As a result, retreading is often seen as a better option for vehicles that experience heavy, slow-moving loads rather than for cars driven at high speeds. Despite the proven benefits of tire retreading, there is still a perception among some consumers that retreaded tires are inferior to new ones. This misconception stems from outdated practices and experiences with lower quality retreaded tires in the past. As a result, some drivers may hesitate to use retreaded tires, fearing that they are less reliable or more prone to failure. Overcoming this stigma remains a challenge for the tire retreading industry, even as technology and quality control have dramatically improved. Educational efforts and awareness campaigns can help mitigate these concerns by informing consumers about the safety and performance of modern retreaded tires. The Eco Extractor 63 is a powerful machine designed specifically to remove steel beads from the massive 63-inch rim mining tires used in the industry. Its reverse hook design allows for efficient extraction of the steel beads embedded in the nearly indestructible rubber tires. This unique mechanism ensures the beads are removed cleanly, which helps in downstream recycling processes. The machine is operated by a single person using remote control, making the operation both safe and efficient. The machine can handle up to 10 tires per hour, offering a high output rate. Additionally, it features an automatic bead ejector that simplifies the bead removal process. With 125 HP of power, this machine is robust enough to process the toughest mining tires. Its dimensions, 22 feet long, 8 feet wide, and 8 feet high, allow it to handle large tires while maintaining manageable space requirements. The Eco Razor 63 is a specialized machine designed for the processing of large off-the-road (OTR) tires, capable of handling tires with rims up to 63 inches. It utilizes a powerful 125 HP system to efficiently remove and process rubber from three sides of the tire. This high-tech machine produces wire-free rubber buffing chips at a rate of up to 1 ton per hour. The machine features an articulating head and adjustable knives, allowing for precise control of the output size. This flexibility lets operators target the most valuable rubber sizes for downstream processing. The dual-head design enables rasping of rubber and splitting of the tire. The rubber produced is ready for screening, packaging, and resale. With a weight of 24,000 pounds and dimensions of 30 by 24 by 16 feet, the Razor is a robust solution for efficiently preparing OTR tires for further recycling or transformation into products like water tanks or wear strips. The Eco Monster is a powerful single-shaft hydraulic shredder equipped with a custom 187 kilowatts, 250 HP, hydraulic power unit. This unit drives a Hägglunds hydraulic motor, providing efficient and long-lasting performance with minimal operating costs. The shredder features a cutting chamber measuring 1,956 mm by 900 mm, containing 18 fly knives and 9 bed knives made from tool steel. These knives shred materials down to sizes as small as 2 inches and are easily replaceable. The machine operates with a low RPM, high-torque shredding technology, allowing it to process up to 12 metric tons of materials per hour. It is capable of handling semi- and OTR tires, after debeating, large truck tires, and car tires. The shredder also processes other waste materials like wood, plastics, and municipal solid waste, including cables, refrigerators, and aluminum scrap. The Eco Monster produces rough shreds of 6 inches and chips down to 2 inches, making it ideal for general waste reduction applications. Its durable design and powerful capabilities make it an efficient solution for municipalities, landfills, and recycling centers handling a variety of challenging waste materials. Semi-automatic tire building technology in China has seen significant advancements in recent years, driven by the growing demand for high-quality tires in the automotive and industrial sectors. Semi-automatic tire building machines, TBMs, in China typically blend manual operations with automated systems, allowing for flexibility, precision, and cost-effectiveness in tire manufacturing. In China's semi-automatic tire building process, machines can assemble multiple tire components such as beads, plies, belts, and tread into a green tire structure. These machines generally consist of 2 stages: carcass building and belt tread application. While the initial setup is handled manually, the critical steps like tension control, material application, and pressing are automated. This hybrid system allows for a production rate of 1.5 to 3 tires per minute, depending on the machine's capacity and the tire size being produced. For instance, Machines dedicated to passenger car tire production typically achieve around 2.5 tires per minute, while larger units, meant for truck or industrial tires, may handle around 1.5 tires per minute. Many semi-automatic TBMs in China are designed with modular configurations that support rapid changeover between different tire sizes and designs. These systems often feature PLC, programmable logic controller, systems, which ensure precision in the application of different tire components, reducing material waste and increasing consistency. The machines also come with advanced tension control mechanisms to ensure uniform application of rubber materials, crucial for ensuring tire performance. Chinese manufacturers are increasingly focusing on improving productivity, with some models featuring automated bead placement systems, sidewall application, and cutting functions that minimize manual handling. These semi-automated systems can produce approximately 400 to 600 tires per 8-hour shift, depending on the tire type and level of automation. The tire recycling industry plays a crucial role in environmental sustainability by converting waste tires into valuable materials and products. Tires, composed mainly of rubber, steel, and textile, are non-biodegradable and difficult to decompose, posing a significant environmental hazard if not disposed of properly. With approximately 1.5 billion tires discarded annually worldwide, tire recycling has become a key focus for both environmentalists and businesses seeking sustainable solutions. This essay delves into the tire recycling process, key statistics, challenges, and opportunities within the industry. Tire recycling process. Tire recycling involves several steps aimed at extracting the raw materials from used tires. These materials can then be reused in various applications, reducing the need for virgin resources and minimizing environmental impact. The recycling process generally follows these steps: collection and transportation. Used tires are collected from different sources, such as vehicle service stations, landfills, or dedicated tire disposal centers. Once collected, they are transported to tire recycling facilities. The transportation process is often costly due to the large size and weight of tires. In the US, about 290 million scrap tires are generated each year, with nearly 80% being recycled or used for energy recovery. Shredding. After collection, the tires are subjected to mechanical shredding. This involves cutting the tires into smaller pieces to facilitate further processing. Tire shredders are typically equipped with sharp blades that can break down even the most rigid tire types. Shredded tire chips, which can range from 50 to 150 millimeters in size, are then sorted for further treatment. Steel removal. Tires contain steel wire for reinforcement, which needs to be separated from the rubber components. This is achieved through a magnetic separation process where powerful magnets remove the steel from the shredded tires. The steel can be recycled separately, contributing to the circular economy. Rubber granulation and powdering. Once the steel is removed, the rubber is further reduced in size through a granulation process. Granulated rubber, commonly referred to as crumb rubber, can be as small as 1 to 4 millimeters. Some processes further reduce it into powdered rubber with a particle size of less than 1 millimeter. The granulated or powdered rubber is then used for various applications, including rubberized asphalt, playground surfaces, and new tire production. Pyrolysis. Pyrolysis is an advanced tire recycling method that involves heating tires in an oxygen-free environment. This process breaks down the tires into valuable byproducts such as pyrolysis oil, carbon black, and syngas. Pyrolysis oil can be used as a fuel or chemical feedstock, while carbon black is often used in rubber manufacturing. The syngas generated in the process can be reused as an energy source for the pyrolysis plant itself. Devulcanization. One of the key challenges in tire recycling is vulcanization, a chemical process that makes rubber durable and elastic. Devulcanization aims to reverse the vulcanization process, making the rubber more pliable for reuse in new products. Devulcanized rubber can be incorporated into new tire manufacturing, reducing the need for virgin rubber. Key statistics in the tire recycling industry. Tire recycling has witnessed substantial growth over the years, driven by both environmental regulations and the increasing demand for recycled rubber in various industries. Some of the key numbers related to the global tire recycling industry include global tire production. Approximately 3 billion tires are produced globally every year, with China, the United States, and Europe being the largest producers. Of these, about 1.5 billion tires reach the end of their life annually. Global tire recycling rate. The global recycling rate for tires varies by region. In Europe, more than 90% of end-of-life tires are recovered or recycled, thanks to strict regulations imposed by the European Union. In the US, approximately 76% of scrap tires are recycled, while in China, the recycling rate is lower, estimated at around 50%. Market size. The global tire recycling market was valued at approximately $9.2 billion in 2020 and is projected to grow at a compound annual growth rate, CAGR, of 3.1% from 2021 to 2027. The increasing demand for recycled rubber in the automotive, construction, and sports industries is expected to drive this growth. Energy recovery. Tires are also used for energy recovery in industries like cement production, where they serve as an alternative fuel source. In the European Union, around 40% of collected tires are used for energy recovery, producing heat and electricity while reducing reliance on fossil fuels. The tire recycling industry is evolving, with new technologies and innovations driving improvements in efficiency and sustainability. Advanced pyrolysis technologies. Innovations in pyrolysis have made it possible to recover more valuable products from scrap tires, such as higher quality carbon black and cleaner fuels. This has the potential to transform pyrolysis from a niche process into a mainstream tire recycling method. Rubberized asphalt. One of the most promising applications of recycled tires is in the production of rubberized asphalt. This material is used to pave roads, providing improved durability, noise reduction, and resistance to wear. States like California and Arizona have been pioneers in adopting rubberized asphalt, leading to a growing demand for crumb rubber. Circular economy. Tire manufacturers are increasingly looking to close the loop by incorporating more recycled rubber into new tire production. By using devulcanization technologies, manufacturers can improve the quality of recycled rubber and reduce their reliance on virgin materials, contributing to a circular economy. Government incentives and regulations. Governments around the world are introducing stricter regulations to promote tire recycling. In the European Union, the End-of-Life Vehicle Directive mandates that 85% of vehicles, including tires, must be recycled or reused. Such regulations, coupled with financial incentives, are expected to drive further growth in the tire recycling market.